Good evening, everyone. We are going to start with question number 28. Suppose f of x is a plus bx when x is lesser than 1. F of x is equal to 4 when x is equal to 2, equal to 1. F of x is b minus ax when x is greater than 1. And if the limit of the function f of x as x tends to 1 is given as f of 1, what are the possible values of a and b? This is the question. Right. Now, let me start by taking the function whatever they have given. They have given that the limit of the function as x tends to 1 for f of x is going to be f of 1. F of 1 meaning that in place of x, if I substitute 1, I will be getting the answer for that. So when I substitute the value of 1 in place of x, what is the answer for f of x? It is going to be equal to 4. So I can write this as equal to 4. This is what is given in the question. We have to find out what is the value of a, what is the value of b. The question says the limit already exists, right? So I can write hence or since the limit already exists, LHL should be equal to RHL. The reverse thing. Yesterday I told you if LHL and RHL both are equal, then limit is going to exist. In this question, they have already given the limit. Then we can understand that both LHL and RHL should be equal. So let me consider the LHL first. I'll be writing over here. Let me take LHL. In terms of a limit, I can write this as limit of f of x as x tends to 1 minus is going to be what? F of x tends to 1 minus, meaning that I should be considering the value of x which is less than 1. Less than 1. So for the less than 1 value, we have the value of f of x as a plus bx. So I can write this as limit of the function a plus bx as x tends to 1 minus is going to be what? I just need to substitute the value of 1 over here in place of x. Doing that, a plus b multiplied by 1. So I will be getting the value of LHL as a plus. This can be taken as equation number 1. Next, I will be considering your RHL, the right hand limit. For the right hand limit, we should consider all the values of x which are greater than 1. Formula for it is given by limit of f of x as x tends to 1 plus. Now the function is going to be when x is greater than 1, I should be considering this function which is limit of the function b minus ax as x tends to 1 plus. Substituting the value of 1 in place of x, I will be getting the value of RHL as b minus a multiplied by 1. I will be getting this answer as b minus a. Let me go to the next slide. Here I will be writing RHL is going to be b minus a. You can take this as equation number 2. Here, since the limit is already given, I can tell both RHL and LHL should be equal. I have got what is LHL, I have got what is RHL as well. I just need to substitute both of them. Substituting both of them, I will be getting from 1 and 2. I can write this way. From equation 1 and equation 2, since both are equal, I can tell LHL is equal to RHL. So I can write this as a plus b is equal to b minus a. This should be equal to 4 because the limit is going to exist. I will consider only the first two equations. Now, a plus b is equal to b minus a. So can I cancel b over here? Yes. Or I can do it the other way as well. So forget this. So what I'm going to do is I'm going to write the same thing. a plus b is going to be equal to b minus a, and this both should be equal to 4. Okay, easy. Now, how do I find the value of a and b? By solving the two equations, can I write this as a plus b is equal to 4, also b minus a, or I can write this as a minus a plus b is also equal to 4. Adding both of them, I can just cancel these. Yes. So I will be getting 2b is equal to 8. B is equal to 8 divided by 2, which is nothing but b is equal to 4. When b is equal to 4, I can find out what is the value of a. A plus b is equal to 4. B is equal to 4. So I can write a plus 4 is equal to 4. Sending 4 to the other side, a will be equal to 4 minus 4, which is going to be equal to 0. Take this as equation number 3. Take this as equation number 4. Finally, you can write the answer as a is going to be 0, b is going to be 4. You have got the final answer. Is that clear? We'll move to the next question. Let me add few more slides over here. This is 29th. Yes. Question number 29. Let a1, a2, an be fixed real numbers and define a function f of x is equal to x minus a multiplied by x minus a2 multiplied by x minus an. What is the limit of f of x as x tends to a1 for some value of a which is not equal to a1, a2 or an? We have to compute the value of limit of x tends to a for f of x. So let me start by taking the function f of x, which is given as x minus a1 multiplied by x minus a2 x minus an. Limit, I will be taking the first limit over here. What is limit of f of x as x tends to a1? Let me write down the same thing. Limit of the function f of x as x tends to a1 is going to be the limit of the function x tends to a1. What is your f of x? F of x is already given over here. The same thing I can consider. So I can write x minus a1 multiplied by x minus a2 x minus an and close the bracket. Now, while substituting the same, what I can do is this limit can be taken for each of the terms. So when I do that, I will be getting limit of the function. Let me write it this way. Limit of the function as x tends to a for x minus a1 multiplied by limit of the function as x tends to a for x minus a2 and All right. Now, when I substitute the value of a1 in place of this, what do you think I'll be getting over here? Will I be getting value of x as a1, or let me take this as a itself? Okay, let me take this as a itself as of now. When I do that, I will be getting the value as a minus a1 multiplied by a minus a2 a minus a n. Yes, a1 minus, yes, what we have done till now is correct. Now I will be writing the limit of f of x as x tends to a is going to be a minus a1 multiplied by a minus a2 a minus a. I'm just substituting the value of a in place of x for all the terms. I'm just writing the first two terms, then it is written till a n. Now if the limit is equal to 0 when I take a1. This is when limit is tending to a, right? X tends to a. What will happen when I take the limit of f of x tending to x tending to a1? When I substitute a1 in place of x, I will be getting the value as 0, is it? Will I be getting the value of 0? It is going to be a1 minus a1 multiplied by a2 minus uh, sorry, this is going to be a, so yes, you can write a1 minus a2 dot dot dot. Since one of the value is 0, I can write the limit of the function f of x as x tends to a1 will be equal to 0. This can be taken as equation number 1. Yes, got it? Now you can write the answer. This is going to be the final answer. Limit of f of x as x tends to a1. For this question, this is going to be the answer. For this function, this is going to be the answer. Yes, limit of f of x as x tends to a1. This is going to be 0. Limit of f of x as x tends to a is going to be a minus a1 multiplied by a minus a2 dot 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 a minus a1. You just have to substitute in the, I have taken this first, then I have taken the second one. All right. Here we are substituting a in place of x. Wherever you see x, you substitute a. In this case, wherever you see x, you substitute a1. Since one of the value is 0, all the value will go to 0. Question number 30. If f of x is mod x plus 1 when x is less than 0, f of x is 0 when x is equal to 0, f of x is mod x minus 1 when x is greater than 0, what is the value of s of a? Does the limit f of x as x tends to a exists or not? Here it is what value or values. Okay, this should be like this, value or value. We can either have one value or we can have more than one value as well. Now I see in the question that there are three cases, right? This is the first case, this is the second case, this is the third case. This is when x is less than 0, this is when x is equal to 0, this is when x is greater than 0. So let me start by writing the function which is given. I can write this as limit of the function as x tends to 0, right? Because the value of x is taken as 0, of f of x is going to be 0. When the value of x is equal to 0, then the value of f of x is taken as 0 itself. Let me consider the LHL and the RHL. For the LHL, I will be getting the value as limit of f of x as x tends to 0 minus, which is going to be limit of x tends to 0 minus when x is lesser than 0. LHL meaning that when x is lesser than 0, I should be considering the first function, which is mod x plus 1. So I can write over here mod x plus 1. Continuing the same thing, I just need to substitute the value of 0 in place of x. When I substitute the value of 0 in place of x, I will be getting the value as 0 modulus plus 1. 0 plus 1 is going to be 0. I can write LHL is going to be equal to 1. You can take this as equation number 1. Next, I will be considering the RHL. Mathematically, RHL can be written as limit of the function f of x as x tends to 0 positive. When x value is taken greater than 0, I should be considering the third equation, which is root x mod x minus 1, writing the same limit of the function mod x minus 1 as x tends to 0 positive. Substituting the value of 0 in place of x, what do you think will be my answer? My answer is going to be 0 minus 1. I will be getting RHL is equal to minus 1, not 0. I'm sorry. So it is going to be 0 minus 1, which is nothing but minus 1. Take this as equation number 2. Since RHL and LHL are not equal, this limit is not going to exist, right? This is when I take the value of A is equal to 0. This is the first case. When the value of A is taken as 0, meaning that this one, I have considered this case, all right? I can write since RHL is not equal to LHL, this limit of f of x as x tends to what is it given, yeah, x tends to 0 does not exist. So this was the case 1. Let me write over here, this is your case 1. When a is equal to 0, I can write the general term here as this. Okay, let me erase this one as of now. Limit of f of x as x tends to a. The first case is when a is equal to 0. Next, I will be considering when a is less than 0. So the second case is going to be case 2. Here the value of a is less than 0. Now I'll be taking the limits again. Limit of x tends to a of f of x. This is the limit. I'll be taking what is the LHL, I'll be taking what is the RHL. Let us find out whether both are the same. If they are the same, then I can tell the limit exists. If not, the limit will not exist. Uh, yes, so I can tell over here LHL, which can be written as limit of f of x as x tends to, what is your a here? It is nothing but a minus. Can I take this as a minus? Yes. Yes, sir. So a minus. Whenever I take a minus, which is the formula I should be using? It is less than, right? A is less than. So what will I be using? The first one. So limit of the function modulus of x plus 1 as x tends to a minus is going to be what? When I substitute the value of a in place of x, I will be getting modulus of x, which is going to be minus a or plus a. What is the value I'll be getting over here? When a is less than 0, minus a. Minus a. What do you think the value of it is going to be? Okay, or else what I'm going to do is, let me leave this as it is as of now. Okay, next I will be considering the limit of x tending to a itself. For when x is tending to a, then I can write this as minus x plus 1. Instead of x, I can write a, so I will be getting minus a plus 1. Next I will be taking the RHL. When I take the RHL, I will be getting the value as limit of x tending to a positive of f of x is going to be what? I need to consider the function, substitute the value of a, I will be getting the answer. Here again, I should be considering the first one itself, even though it is your RHL, I will be considering the first one itself because I have considered a is less than 0 for this function. Now I will be getting the value as mod x plus 1. When I substitute the value of a, what do you think the answer is going to be? Minus a plus 1. Minus a plus 1. This is going to be the RHL, or let me write this way. RHL is going to be minus a plus 1. Even your LHL is going to be the same thing. Yes, LHL I can write over here. LHL also is going to be minus a plus 1. Now if both are equal here, RHL is equal to LHL, then I can tell that the limit is going to exist when x is equal to or x is lesser than 0, right? When a is less than 0, limit exists. So case 1 is done when a is equal to 0, case 2 is done when a is less than 0, the third one is going to be when it is going to be case 3 for a which is greater than 0. Whenever I take a which is greater than 0, what do you think the value of the limit is going to be? So let me write the value of RHL over here, or first let me take the LHL, then I'll go with the RHL. LHL is given as limit of f of x as x tends to a minus, and let me write the RHL as limit of the function f of x as x tends to a positive. When I have taken a negative and a positive, meaning that LHL and RHL, what is the value I should be considering? It is going to be mod x minus 1, because here in this case x is greater than 0, meaning that even a is greater than 0. How do we read this as? Limit of f of x as x tends towards a. So if a is greater than 0, can I tell even x should be greater than 0, because x value is going towards a, right? So I can write this as limit of mod x minus 1 as x tends to a minus. Here it is going to be the limit of mod x minus 1 as x tends to a positive, right? Now substituting the same, I will be getting a minus 1 as your LHL. Substituting the value of a in the RHL, I will be getting RHL also as a minus 1. Since both are equal, the limit is going to exist. I can write that limit of f of x as x tends to a exists at a greater than c. Yes, I will move on to the next question, which is the 31st one. If the function f of x satisfies limit of f of x minus 2 divided by x square minus 1 as x tends to 1 is given as pi, we have to evaluate the limit of f of x when x is tending towards 1. All right, let me write down the function given over here. The function given is the limit of the function f of x minus 2 divided by x square minus 1 as x tends towards 1 is given as pi. This is what is given in the question. We have to find out or evaluate the limit of f of x as x tends to 1, right? Whenever I write the same thing, I can write limit of f of x as x tends to 1 is going to be 1. What do you think the value of f of x is going to be here? Can I write this as, when I substitute 1 in place of x, here I will be getting f of x minus 2 divided by x square is there. So I can write this as 1 square minus 1. Will I be getting that as 0? Yes, sir. Yes. So can I substitute directly? Can I substitute directly, or should I be doing something else? Factorization. Factorization? But how will I cancel over here? I cannot cancel, right? Can I cancel or not? No? No, sir. No, I cannot cancel. So what do you think I can do over here? I can take the limits as two different entities, meaning that I will show you this way. Okay. Now, limit of the function is this, yes, this one, as x tends to 1 for f of x minus 2 divided by x square minus 1. Now this can be written as limit of function as x tends to 1 for f of x minus 2 divided by the limit of x tending to, okay, we have gone to the some other, yes, sorry, where did it go? This is the derivative one. Okay. Yes, we were here. Right. Now, limit of x tending to 1 for x square minus 1. The only thing which we have done is this limit x tends to 1 was common for both of them, both the numerator and the denominator. I'm just writing it separately. All right. Yes. Yes, sir. Okay. Now I'm going to substitute the value of 1 in place of f of x. All right. Upon doing that, I will be getting over here limit of the function x tending to 1 for f of x minus 2 is going to be, I can write over here pi multiplied by, can I send this is equal to pi? This is what is given in the question, right? This is equal to pi. Now can I multiply this over here, cross multiply? So I can write limit of the function f of x minus 2 as x tends to 1 divided by limit of the function x square minus 1 as x tends to 1. If it is equal to pi, I can keep the numerator as it is, I can send the denominator to the other side. So here I will be getting pi multiplied by limit of the function x square minus 1 as x tends to 1. With me? Now I just need to substitute the values and get the answer. Substitute x is equal to, right? When I substitute the value of x is equal to 1, I will be getting over here limit of the function as x tends to 1 for f of x minus 2. It will remain as it is because I don't see any x. I have f of x but I don't see any x, right? So I need not substitute, but over here I have x, so I can write this as pi multiplied by 1 square minus 1, which is going to be 0. 0 multiplied by pi is also going to be equal to 0. I will be writing limit of x tending to 1 for the function f of x minus 2. This should be equal to 0. Right? Now, I will be taking the limit for both this one and this one. So, multiplying the limit or taking the limit for both of the terms, I can write this as limit of the function of f of x as x tends to 1 minus limit of 2 as x tends to 1. This is going to be equal to 0, right? Now, when x tends to 1, the limit of 2, what is going to be the limit of 2? We don't have any x, so this value is going to be just 2. Yes? So I can write over here the limit of the function f of x as x tends to 1 minus 2 is going to be equal to 0. Hence, limit of the function f of x as x tends to 1 will be equal to, this is going to be equal to, is that clear?